Today I will discuss about Thevenins theorem. So Thevenins theorem states that in a linear bilateral network, the network containing voltage sources and resistances can be replaced with a single voltage source in series with resistance. Suppose linear bilateral network. So, for example, I am taking a simple circuit. It consisting of one voltage source and resistances. So, voltage source Vs is equal to 10 volts and R1 is equal to 100 ohm. R2 is equal to 100 ohm and R3 is equal to 47 ohms. So this one is the load resistor RL. So this complicated circuit can be reduced to a simple voltage source in series with the resistance. The voltage source is VTH and resistance is RTH. So here VTH is nothing but VTH is equal to Thevenins voltage and RTH is nothing but Thevenins resistance. First, we are finding VTH, then after we can find the RTH value. So, first finding of VTH. Finding of VTH. So, to find VTH value, first step is to remove the load resistor. So, first from the original given circuit, I am removing load resistor RL. So this value is 100 ohms, and this one is source voltage. Source voltage is 10 volts, and this is also 100 ohms. This is R1, and this is R2, and this one is R3. R3 is 47 ohms. 47 ohms. So for this circuit, first to find out VTH value. VTH value is nothing but open circuit at voltage across the AB terminals. VTH value. So I am looking from the open circuit at terminals. So this resistance is visible to me. That is nothing but R2. The voltage across R2 is nothing but VTH. The voltage across R2 is nothing but VTH. So here VTH is equal to I into R2. I into R2. So we can find out the VTH value. VTH is equal to I into R2. So to find out VTH value, first we have to find out the I value. I is nothing but current flowing through this particular loop. So here, according to Ohm's law, I is equal to V by R. From this equation, so here supply voltage is nothing but 10 volts. R is nothing but these two resistances are in series combination. R equivalent. So R equivalent is equal to 100 plus 100. That is 100 plus 100. So this one is 100 by 10 by 200. I value is 10 by 200. So this one is I value. So substitute I value here. So here VTH is equal to 10 by 200 into R2 is nothing but 100 ohms. 100 ohms. So 2 times, and here VTH value is VTH value is 5 volts. So Thevenins equivalent voltage is always less than the source voltage. Suppose if you take the original circuit, the source voltage is 10 volts. Here Thevenins equivalent voltage is 5 volts. Thevenins voltage is 5 volts. Thevenins voltage is always less than the source voltage. So next step is to find out RTH. Next step is to find out RTH value. So here we got the VTH value 5 volts. So VTH value we can find out in different ways. We can find out with the help of nodal analysis also. This is with the help of basic Ohm's law we are finding out VTH value. With the help of nodal analysis also we can find out Thevenins equivalent voltage. There are different ways are there to find out Thevenins equivalent voltage. That is nothing but VTH value. So I will explain another method also, that is nodal analysis method. So by using nodal analysis method also we can find out Thevenins equivalent voltage. So nodal analysis method. Nodal analysis method. So here unknown voltage is VTH and higher potential is positive and lower potential is negative. So higher VTH minus this potential is 10 divided by resistance value is 100 plus VTH divided by 100, that is equal to 0. So here we are neglecting this 47 ohm branch. Why? Because current flowing in 47 ohm branch is 0. Why? Because these AB terminals are open circuited. So we are neglecting this 47 ohm branch. So here two branches are present. That's why we will get two equations. VTH higher potential minus lower potential, that is 10 divided by branch resistance, that is 100, and another branch is VTH divided by 100. So here suppose if you solve this equation, VTH divided by 100 minus 10 divided by 100 plus VTH divided by 100 is equal to 0. Suppose if you solve this equation here also, we will get the same VTH value is equal to 5 volts. So in different ways we can find out VTH value. Okay, next to find out Thevenins equivalent resistance. To find out Thevenins equivalent resistance, so okay, we know that to find out Thevenins equivalent resistance, okay, first we have to short circuit the voltage source. If there are here in this circuit only one voltage source is present. If a voltage source is present, we will short circuit that particular voltage source. If a current source is present, we will open circuit that particular current source. Simply we will turn off the sources. Then after we will find out the Thevenins equivalent resistance. So here only one source is present, that is voltage source. So voltage source is turn off. Turn off means we will short circuit the voltage source. So here voltage source is present, that is 10 volts voltage source. So I am short circuiting 10 volts voltage source. 10 volt voltage source. That is the step. Second step is that is finding of RTH, Thevenins equivalent resistance. So 10 volt voltage source is short circuited. So again I am looking back from the open circuited terminals. So the voltage across the resistance across AB terminals is nothing but RAB or Thevenins equivalent resistance, both are same. So here RTH is equal to so this one is R1 and this is R2 and this one is R2. So here R1 and R2 are in parallel connection, and again R3 is in series with this combination. So here R1 is in parallel with R2 plus R3. So suppose if two resistors are in parallel combination, to find out equivalent resistance R1 R2 divided by R1 plus R2 plus R3. So substitute all the values then we can calculate the RTH value. So RTH is equal to R1 value is 100 and also R2 value also 100 divided by 100 plus 100 200 plus R3 value is 47 ohms. So here RTH is equal to 97 ohms. RTH is equal to 97 ohms. So already I got the value of VTH value and also I got the value of RTH value. So here what? So VTH value is 5 volts and RTH value is 97 ohms. So this is nothing but this circuit is nothing but Thevenins equivalent circuit. This one is Thevenins equivalent circuit. So the application of this theorem is to find out to reduce the complex network into a simple network. Suppose if you take this one is a complex network. So with the help of Thevenins theorem, we are reducing the complex network into a simple network. So the complex network can be reduced to a simple network. That is the application of Thevenins theorem. And also this theorem is used in power system analysis and electrical circuit analysis, transmission lines in different, and also in electronic circuit applications also this theorem is used. So to analyze a particular electrical circuit, this theorem is used, and also to find out individual branch currents or individual load current also we can find out. So in particular RL is nothing but load resistor. So we can find out the load resistor across current flowing through RL also we can find out. Suppose the current flowing through RL is IR is nothing but load current. RL is load resistor. So that is step 3. We can find out load current also. We can find out the voltage value, we can find out current value, and also we can find out the equivalent resistance value also. So we can find out IL value also, that is load current value also we can find out. Suppose if again I am connecting load resistor RL to the Thevenins equivalent circuit. So it is a closed circuit. Previously it is a open circuit. After connecting load resistor across AB terminal C, after connecting load resistor across AB terminal C, it is becoming a closed circuit. So current always flows in a closed loop. We know that. So we can find out IL value also. So IL value is nothing but load current. So IL is equal to load. So IL is equal to load current. So here IL is equal to that is nothing but current flowing through the load resistor. The load resistor value can be 50 ohm, 60 ohm, 10 ohm, 100 ohm, 20 ohm, whatever it may be. Whatever may be the load resistor value, we can find out current flowing through the load resistor with the help of Thevenins theorem. So the main application is we can reduce the complex network into a simple network. So here IL is equal to VTH divided by RTH plus RL. IL is nothing but load current. IL is equal to VTH divided by RTH plus RL. So here VTH is nothing but Thevenins equivalent voltage and RTH is nothing but Thevenins equivalent resistance. It is measured in terms of ohms, and RL is nothing but load resistor RL. It is